Okay. So now Q. Okay. Q is a data structure. Now see Q collection. Now as I told you, stack. Stack was first in, last out. Correct? First in, suppose I have entered a book A, okay, and I have entered a B, and I have entered a C. So which one will come out first? So this one will come out first. Correct? Last in, first out. Leave. Okay. Last in, but first out. Okay. And the first one will be last to get out.
Mhm.
Okay. So this is your stack. Now what is a queue? Now queue is your
First in, first out.
first in, first out. Okay. Queue is like this. Okay. Suppose you are entering a book A. So from here you will enter and here you will remove. So if you have entered A, so A will be the first to be removed. B will be second to be removed. C third, D fourth. Getting it? So it is the first in, whatever you will enter first, that will be first out. Okay, first in, first out. This is your people. Okay, so Q is your FIFO. Now this is your FIFO. Now Q. Now let's see the methods and the thing of Q. Now Q is an interface. Q is an interface. So in Q we have two subclasses. Okay, array DQ and a priority queue. Okay, array DQ and a priority queue. Now let's see. So first of all, let's talk about the queue. So it's a queue. Okay, and inside queue you have a some integer type. Array DQ. Okay, this is how you create a queue. So let me import the package. Java.util. It is present in Java.util and this is also present in Java.util.next. Array DQ. Okay, now you can add q.add 10, q.add 15, q.add 3, q.add 1. Okay, like this. Q.add 6. So if I will remove, which element will be removed first? Tell me. Print element. Which
10.
element will be
10.
removed first?
10.
10. Okay. Q dot remove. Okay. Q dot that will remove 10. Okay, why? Because it is present on the top. Okay, so if you will do peak, peak means what is on the top. So what is on the top? 10 is on the top. Okay, 10 will be the one which will be removed. 10. Okay. Got it till now? Any doubt? Okay. So there are a lot of method in Q again. Add all, as I've already explained. If you want to add all the all the collection, so you can use add on. Okay, and you can see this is a method of the collection interface. Contains will tell you whether the particular element is present inside Q1. Contain all will tell you whether the whole list is present in that or not. Okay, equals will tell you whether the two queues are equal or not. As to is empty will tell you whether the queue is empty or not. Okay, so these are your small methods. Size will tell you whether the what is the size. Okay, so these are the things. Take, pop. Okay, Q method. Remove to array if you want to convert it into array. So this is your topic of your Q. Got it,
So
guys?
here we can give index as well.
Hmm?
Can we give index of the number as well?
No, no index.
Okay, if we want to remove 10 and 15, we need to do call that method 2 times.
Right.
First
Okay, you
it
have
will
to
remove
remove
10,
one
then
by
it
one.
will
Yeah, one by one you have to remove.
remove.
Okay.
Okay.
Now, second subclass of queue is your priority queue. Okay, priority queue. Priority queue basically have no order. It what it does, it arrange the element according to priority. Okay, according to the priority. Okay, like if I will run this, I will try to print queue. So if you will run this, so what will happen? See, 1, 3, 10, 15, 6. Can you decide the order? See, order is not decided. 10, okay, it is not in a ascending order also. You can see 1, 3, 10, 15, 6. Okay, it is an unorder. So if you will try to print it, it will give you unorder. It will give you according to the priority. Okay, so according to him, this is a priority of the elements. Okay, so this is your priority. Majorly people use array DQ only because it's your first in, first out. So this is your queue. Okay, now okay, diamond shape operator. This one you are talking about. This one. You. So this is called a generics. Okay, generic. This is called a generic. Generic means where you will define the data type of that list. Okay, what type of data you want to store in a queue, or what type of data you want to store in a stack. Okay, although if you will not give this also, it will not give you error, but it will say it will be any type. It will be like you are creating object type. You can enter anything. You will have no rules on your data. You can enter string, integer, character, array, anything. Okay, that's why Java is saying, yeah, this is not a good idea. You should give a particular data type. Okay, what type of data you are storing in that list. So that's why we have generics, where you define the data type of that list, and this data type will be a wrapper class. Okay, wrapper class means the predefined class for primitive data type, like int, okay, char. Okay, these are the primitive data type. These are not a predefined data type. So for that, we are having a wrapper classes. It means it is a predefined class. Okay. So I hope everyone is clear with the topics now. Okay. So this was your queue. No problem. Okay, so queue, array queue, family. Okay, now we have set. So set is also unique data type. Okay, structure. Or you can see unique collection. Okay, set is saying I will give you the list. You can store anything, but I will remove the duplicacy. I will remove the duplicacy from the list. Okay, simple. That is saying you can use me as a list. You can use me as a list, but I will remove the duplicacy. Simple. Okay, so what is the use of set? If you want to remove the duplicacy, you can use set. You can say set is equals to new. Now set is the interface. So in set also we have three subclasses. First is your hash set, a normal set. Okay, hash set. Second is your linked hash set. Third is your uh, tree set. Third is your tree set. Okay, so first of all, let's see hash set. Hash set. This is a subclass. Okay, or set. So if you will, let me import this. Okay, I'm not getting the option. So let me import by myself. Import java dot set. Import java dot util dot hash set. Okay. So I've imported it. Now see what I will do. Set dot add 10. Set dot add 3. Set dot add 10. 10. Set dot add 6. 6. Set dot add let me over. Set dot add 5. Set dot add 6. Set dot add 10. Okay. System dot out dot println. Okay. See, so in fact, what we have done, we have removed all the duplication. We don't have any duplicate element in our set. Getting it? 3, 5, 6, 10. So you have removed all the duplication. Okay. So see how useful the set is. If you want to remove the duplicacy, you can remove using set. But now set is saying, yeah, you are using hash set. Hash set means it will not give you any structure, means it will not give you the data as you accept. It will give you random data, means it is not arranged. 10 can come over here also, 3 can come over here also. Like the order is not fixed. The order is not fixed. Okay, if you will see, now see 3, 5, 6, 10. If you will run again. Right now I'm having small data, so I think it will give you the same output. Although if you have a large amount of data, you cannot predict the output. Okay, it can be in any order. It can be in any order. Now let me add something else.
When you try to remove element, what order does it follow, sir? Like LIFO or FIFO?
Let me tell you. 1, 3, 5, 10, 6, 10. Okay, 1, 3, 5. It is it is showing ascending order, but it will be an order. Okay, always remember this hash set will be an order. Okay, you are saying the ascending order, but it is not in ascending order. Why are you not at 100? Okay, now see, it is not in ascending order. Okay, it's in unorder. Okay, now set dot remove. So you can say you can directly remove any element if you want to remove. If you want to remove 5, you have to say 5. 6. 5 will be 1 second. I have to print after this. Now the question is, sir, in which order it will remove? See, it will remove 5. Now, set is also having no index. Why? Because as I've told you, hash set have no particular order. One is on the top, one can be at anywhere. It can be over here also. It can be over here also. So it is difficult to say that which element is present at what index. So that's why set is saying if you want to remove any element, you can tell me which element you want to remove. I will remove that element from the list, because in list you will have no in set. Okay, in set you will have no duplication. If you are writing 5 times, it will only be shown 1 time. So if you want to remove 5, it will only remove 5 1 time, and that's all. List will not have 5. Okay, so it is also not having any index. Okay, so that is also having many options. Add all, clear, contains all, equal, is empty. Okay, size. Now the thing is, sir, if I want to use it, if I want to print all the elements without system.out.println, or if I want to do any kind of operation, how will I do that? So now here we are having 2 things. One is enhanced for loop. One is your enhanced for loop. Okay, what is enhanced for loop, or we can say for each loop? Okay, so this is your for each loop. Yeah. And before for each loop, let me explain you one more thing. Iterator. Iterator. ITER. Iterator. Okay. Over here, you will tell where which type of element is integer. Iter is equals to set dot iterator. Now this will work as a for loop. Okay, this will also work as a loop. Okay, so what you will say while iter dot has next. It will tell you whether the set is having next element or not. Okay, and you can do any operation. If you want to print it, you can say iter dot next. Go to the next. It will work as a pointers. So if you will run, it will print your C1306 step. Okay. What you are doing? You are saying iterator, and now iterator. Okay. So you are saying iterator dot has next means, does this set have another element? Yes, 3. It is having the next element. Okay. So he will say iter dot next. It will print this one and he will come to 3 now. It will work as a pointer. Okay. You are having pointer over here now. So iter is saying iter dot next. Do we have next element? Yes. Okay. Print the 3 and go to the next element, 100. Okay. Do we have next element? Yes. Okay. Print the 100, go to 6. Do we have next element? Yes. Print 6, go to 10. Now we are at 10. Okay. So it will say, do we have next element? No. So it will print 10 and it will go outside the loop. Okay. So this is your iterator. Any doubt in iterator?
Sir, can you
No.
please go again?
Again. Now. Okay. Now see, you are creating a set. This is your set. Okay. Inside set, you will have only the unique element. So first. Okay. It can be in any order. Okay. It can be any order. You cannot decide the order. 5, 10, 100. Okay. Now 3. Okay. Suppose this is only the unique elements. Okay. Now you are saying remove 5. So 5 will be removed. Okay. Now iter dot set, iter dot next value. Pointer is over here. So I'm saying, do we have next element? Yes, we are having the next element. Okay. It will return true. So I will go inside the loop and I will print 1 because I'm printing 1 and I'm saying go to the next. Okay, iter dot next, go to next. So my pointer will point to 10 now. Now, do we have next element? Yes, we are having the next element. Okay, print 10 and go to next element. Okay, now I'm over here. Do we have next element? Yes. So print 100, go to next element. Okay. Okay. Do we have next element? No, we don't have. Okay. This will be the last time. Okay. So he will print 3 and he will go outside the loop. Loop will be ended. Okay.
Yes, sir.
Okay. So this is your iterator.
Okay. Now got it.
Sir, what is the use of this? Like,
Set.
when we are printing the set dot add, also it is showing the same thing. But what is the exactly use?
This iterator.
Yes.
If you want to run in the loop because it doesn't have an index, so you cannot use for loop like you cannot use ij. Okay, like I is equals to 0, go to 3, and because it doesn't have index. So you cannot use that loop. So instead of that, if you want to use loop, if you want to do any kind of operation, you can use this one, or there is one more thing which is called for each loop, or you can say enhanced for loop. That is also same thing. It will also see basically this and the enhanced for loop doesn't depend on the indexes. They will just run your anything. Okay, list, chat, anything. Got it?
Yes, yes, sir.
Now this is further enhanced for loop. You will say like what type of value you are having? Integer type. You will say integer. Okay. Any variable, any. You can write anything. I'm saying value. Value for value. This and that. This thing. Okay, this thing. This. If you are writing answer, you have to write answer over here. Okay, this is the name of that thing. List. And this is a variable. You are creating a variable, integer type of value. Okay, now you can use it. Inside val, you will have value one by one. You can say this.
Can we use only for set, or can we use this the same thing to queue and
Yeah,
start?
yeah. You can use it anyway.
And also,
So
if
can
I want to like take one variable in between the like 100, I want the 100. How can I?
In between the set.
Okay, in between the set.
No,
Okay,
no,
good.
like I'm asking the question. What you are saying?
In the set, the 100, I want the 100 element only to be printed. This is like a loop, right? We don't
You
have indexes.
one second. You are saying that I want to print 100 two times.
No, only one time. I want to pick 100 value for my other purpose. Suppose I
Okay.
want to only 100.
Okay, no problem. What you can do, you
How
can
can
write
I?
if element, if
Okay.
val is equal to 100. Do whatever you want to do inside this.
We need to put the condition for
Hmm.
that. Got it.
Yes, sure.
so can you please show for each also?
This is your for each.
Just for no, there was one element also which was using for each. Each was also written with it, and then the value was there.
No,
I tried, but I couldn't get the value, so I'm asking.
no problem. See, this is also your for each and also this is only the for each. Don't worry. We
So
call
we
this
don't have
as-
to write each with for.
No. This is only the thing. Okay, this is
Oh,
only
okay.
your
Thank
for
you.
each. For each element. Okay, for each.
Usually used in bash scripting.
Everyone is clear with this? Okay. Now the second type of hash set. Now, as I have told you, in hash set, we cannot decide the order of the elements. Okay, like where will one be there? At the top, at the bottom, at the end. You cannot decide the order of this. Okay, but now we have one more subclass which is called your linked hash set. Linked, LINKAED hash set. Okay, this is called your linked hash set. It is saying it will give you the order. Which order? Insertion order. Okay. Linked hash set will give you the order. Which order? Insertion order. Okay. Like if you are saying that I will insert one. So he will give one at the top. Okay. One will be the first one. Okay. In the list. Then you are saying three will be the second one in the list. It will maintain an order. Which order? Like 1, 5, 10, 100, 3, 6. Okay, this will be the order 1, 5, 10, 100, 3, 6. Okay, 5 also 1, 5, 10, 100, 3, 6. This will be the always order. See, if you will print, okay, let me print also.
Means a link hash set will be used to maintain an order,
Insertion order.
insertion order.
But the 5 is not displayed in this. Why?
I have removed the 5.
Okay, sorry.
See, now 5 is also there. 1, 5, 10, 100, 3, 6. This will always be order. Okay, so this is your linked hash set. Okay. Now third, this one is I think clear. Every method is same. This is a, yeah.
So, do we have any method to remove the duplicates in a queue or array list? Do we have
That's
any
why we are
method?
having set. That is why we are having no. Okay, so
Oh.
basically this is only the thing. Okay, collection is saying you can do anything, yeah, you can do anything. If you want to remove duplicate, use set. If you want FIFO LIFO, use queue or stack. If you want normal list, use list, array list, or linked list. Okay, so he is saying you can do anything. I am giving you that you can manipulate whole data according to you. Okay, if you want to remove duplicate plus you want insertion order, use linked has set. If you want to sort the element and you want to remove the duplicacy, use reset. The third type. What reset will do? He will sort your data plus he will remove all the duplicates. This is a third type. See, 1, 3, 5, 6, 10, 100. It will sort the data plus it will remove your duplicates. So collection is saying you can do anything, anything. Okay, if you want to keep a normal list, use array list or linked list. Okay, if you want to use FIFO LIFO, use stack or queue. If you want to remove duplicates and you need just you only remove two duplicates, use hash set. If you want to remove duplicates plus you need order, use linked hash set. If you want to sort the element plus you want to remove the duplicate, use reset. Okay, so these are the types of collection. And collection is also saying we are having a predefined class, collections. Okay, in which you can reverse array, sort array, you can do anything. Okay, so this is the power of your collection. That's why people say in Java we are having collection, we can do anything.
Mm,
Okay, in other language you have to perform for loop, condition, this, that. But in this, just use collection. If you do want to do anything.
Okay. This
And
this
it
for
will
loop looks
correct.
different kind of thing which
This is
we
called a
don't.
for each loop. For each loop, or you can say enhanced for loop. Okay, in which if you don't have index, use this one. And majorly people use this one only.
Okay.
Okay. Now there was one more thing I have to do. Okay, if I will remember, I will tell you. But this is a collection. Okay, so you can do anything. You can manipulate whole data. You can play with the data if you want. Okay. Plus, Java is also saying, yeah. See, if in other language, in other languages, and plus it will give you O1 of solution. O1 means O1. O1 is saying if you know the time complexity and space complexity, it is very important to maintain this. Okay, like how much fast is your program? That is your time complexity, how much time it is taking. Okay, so it will give you O1, which is the best. Okay, O1. If you are running the loop, it will give you ON because you are running the loop n times. Getting it? So you can do anything in O1, which is one of the most important best. So using collection, you can do that. Okay, like collection is giving you a lot of advantages. Okay. Although we are having stream API also, and stream API is saying no need to write conditions. I will give you everything. So we are having a lot of things in Java. You can do anything. Okay. So this is a collection. Now we have one more topic, which is called a hash map. Okay, map. Similarly, we are having map also. So do anybody know about enum? Enum. Have you heard about the name enum?
Enumerator.
ENUM, enum.
Yeah, it's there in C.
No, it's in Java also.
Yeah.
Okay, I will tell you that also if you want. Okay, let me finish the collection. Maps. Now we are having one more topic, map. Map is saying, yeah, suppose you want key value pair. Okay, now you are storing the value. Now you can manipulate the single data. But what if you want to contain a list like key value pair? Like you are saying, you are having a list. Okay. Over here, you are having one roll number, and the one roll number is Rajesh. 13, Piyush or Pihu. 10, you are having Lucky. 15, you are having Ricky. Okay, so you are having key value pair, correct? This is the key. This is the value. So what if you want to store this kind of data? So you can do that also. For that also, Java is saying you can do this also if you want. So for this, we are having hash, sorry, in map. In this, we are having map. So in map also, we are having 3 types. Okay. Hash, map. We are having hash, length, hash, map. And third is your free map. Okay. And similarly, we are having hash table also. I will tell you the difference of hash table also. Hash table. Okay. So hash map. It will also store the values in key and value pair only. But what if I am saying this? 17 or 19 is equals to Rajesh. Okay, it will store it. It will store it. Now the value will be 1 Rajesh, 13 Pihu, 10 Lucky, 15 Ricky, 19 Rajesh. Correct, which is correct. But what if I will say 1 is equals to Robin? What is this now? So this will remove this element. Okay, and the latest element will be this now. So 1 will have Robin now. Okay, not Rajesh anymore. So if you will do any work after this, so 1 will have Robin, not Rajesh. Okay, means value can be duplicated. Values can be duplicated, but key will be unique. Key will be unique. Values can be duplicated. Getting it, guys? Getting it or not?
Yes.
Okay. Now let's do some
Sir,
questions.
sorry. Did we cover that tree set in a set?
Yeah, tree set. I think the tree set is normal. If you want to remove all the duplicates, plus you want ascending order, use tree set. Okay,
Oh,
everything will be same. As everything will be same. Tree set is this only. If you want to remove the element, plus you want to sort your data, like ascending order. So use tree set. Okay. Now let's do the topic. Now let's do some questions, like how to use it. Let's see. So map is an interface. We can have 3 subtopics. So first is your hash map. Hash map. So key. Now what type of key you want to be? Integer, string, any type. You can give any type. In generic, you can give any type. You can also give class type, predefined, user defined. You can give any type. Okay. Suppose I'm saying key will be integer and name I will use key and value string and this. That is equals to new hash map. Let me insert the data. Yeah. Okay, so this is your hash map. So now suppose I'm saying map.put. Okay, to add the element, we have map.put. Map.put. So I'm saying 1 will have Rajesh. Okay, map.put. 13 will have the map.put. 20 will have from map dot put 30 will have Robin. I'm saying map dot put 1 will have P. Okay, 1 will have P, and before P, and let me remove this first of all. Let me show you what will be the output. So if I will say system dot out dot println, and if I will say map, so as he is already having two string method, so he will print the values according to key value pair. See 1 Rajesh, 2 Ramin, 13 P2, 30 Robin. Okay, now if you will say map dot put 1 P2 again. So it will give you 13 P2, 20 Robin, 30 Robin, okay, 1 P2. Okay, like this. 1 P2, 20 Robin, yes. And hash map also will have no order. No order. Okay, order can be anything. It can be random. You cannot say that 1 P will be on the top 1 P. It can be on the third also. Okay, it can be anything. So it is in an order. Got it? So this is your hash map. Now in this we are having lot of methods. Okay, suppose you want to find key value. You want to work as key value. So you can use for enhanced for loop. You will say, suppose you will work on the key. Okay, so you will say integer, integer, integer. Well, and you are working on the key. So you will say map dot key set is a method which will return you key. It's a set of key. Okay, key set. See, it will return you the set of integer value. Okay, why? Because it is in integer type. And it will be unique also, as I have told you. Getting it what I'm saying? Key will be unique. I have told you in map, the key will be unique, value can be duplicate. So unique, okay, and integer type. So if you will say map dot key set, it will return you the set of the key, okay, which will go one by one in val. Okay, now you have a set of the key. So you can do anything. If you want to print the value, you can print the value. You can say val dot value. Okay, value and value of me. Val dot key value, val dot, and val will print your value. Sorry, get, yeah, dot get. It will print the value. So get, you will say val. So it will pass the value. For key, it will give you the value. Val dot get, and get we are not having the method. Map dot get, no, not map dot get. Map dot get. Okay, over here you will pass the key and it will return you the value. Okay, now it will print Rajesh according to this. It can be anything. Okay, unorder. As hash map is unorder. Okay, so get,
This
and over
key-
here you will
key
pass the value. And it
duplicate,
will,
so we are not.
Hmm?
Yeah, Rajesh. Why it's not printing Rajesh? Because this
because
one
I
is
have overridden
duplicate
that.
key.
Yeah, key will be unique. So I'm saying one
Overridden.
Rajesh, 13 this, and I'm saying one P
Then
now.
we are overriding.
So it will replace
Okay.
this Rajesh to P.
Okay.
Getting it?
Okay.
Okay. So in val you are having key. You are saying map dot key set. It will return you the set of keys. Okay, and it will go one by one in val. And with the help of get method, you are getting value. Map dot get. Over here you will pass the key and it will return you the value. Okay. Although we are having a lot of method in map also, like map dot clear flow compute. Okay, contains key. Contains key will tell you whether the key is present or not. Okay, like you are saying 15. So you will say map 15 is present or not. It will return you true and false. Okay, contains value also. Okay, this is for key, this is for value. If you want to check the value, whether the key is present or not. So it will tell you true and false. If it is present, then true, otherwise false. Okay, so we are having a lot of methods. You can explore them. Okay, entry set, for each. Okay, this is the for each. And this is only the for each. Okay, don't run. This is also part of for each. Don't worry. Okay, use this only. Otherwise, the more you will go, the more you will confuse. Okay, get or default is a very good method. You can explore it. Please have notify put all remove replace. If you want to replace, also you can replace using key. Okay, suppose you want to replace now. You are saying that at 20, I want to put anything else. So you can use it. Okay, so this is your hash map. Now, what is the linked hash map? linked hash map if you will write, so it will give you LIN. Okay, it will give you same order, insertion order now. Okay, same as your insertion order. See, PU, Robin, Robin. Okay, PU, Rajesh is removed. Now PU we are having. Okay, then we are having PU. Why PU? Okay, it will be replaced now. One PU over here because one I'm inserting at the top. So PU will come over here. PU, Robin, Robin. Okay, so same order as insertion order. Okay, so this is your linked hash map. Now third is your tree set. Okay, so let me for tree set. Oh, sorry, tree hash map. Let me write 2 over here. So if I will run this in linked hash set, it will be same. PU, Robin, Robin. But if I will write tree over here, so it will sort according sort the key. T or W. Tree map. Okay, and over here, anyway, so it will give you according to C. PU. First of all, PU. First, second, Robin, and then third will be PU, and fourth will be Robin. See, so this will be sort according to the key. Got it, guys? So this is your tree.
This is according to
Sort, depending order of key.
Okay, keys.
Keys. Okay. Now this is your whole map also. Okay. Hash table will also work as same hash map only. Let's see the difference. Only the difference is one is synchronized, another one is not. One is fast, another one is slow. Hash map is boost, hash table is not boost. It is synchronized, that's why it is slow. Okay. It is non-synchronized, it is fast. It is not thread safe, it is thread safe. Okay. It is Java 1.2 before this. Okay. It is fast, it is slow. Okay. And you can store null over here. You cannot store null over here, but you can use null over here. Okay. So this is only the difference, small difference. Basically, people use hash map more than hash table. Okay, according to like I personally use it. So I think today I think this is sufficient. Tomorrow what we will do, iterable iterator. Okay, and some new features like lambda expression. Okay, functional interface. So this kind of things we will do tomorrow, and then we will start our new topic, exception handling, multi-threading. Inner class is all. I think inner classes is done. Exception handling, multi-threading is only left now. Which is important for you. Got it? Okay. Okay, guys. Bye then. I will upload the recording. Watch the recording. Okay, today for sure I will upload the recording from 10 now. Friday
9.
9 also.
Yeah, because somebody said 9 also
Okay. 9, 10. I will see.
in the chat.
Okay.
Yeah.
Okay, guys. Bye.
Thank you.
Okay, bye. Have a good day. If anyone have a doubt, they can ask. What out? Oh, bye.
No.